So this open middle problem builds off the last one on complex numbers. It says, using the integers -9 to 9 at most one time each, place an integer in each box to make a real number product with the greatest possible value. So the first thing challenging here is just, I think a lot of people are going to think that it's not actually possible to make a real number product. You've got an imaginary number here, a complex number with a real and an imaginary component, and people are going to think that's not possible. And so the first thing they have to kind of realize is, well, are there values, are there integers that you could pick that would make this actually become real? And so one of the things that I think people realize is if you think about it like factoring, I'm not a big fan of you saying FOIL, but if you think about this in terms of distributive property and factoring or multiplying them out, if these right here and these terms right here are going to be canceling each other out, then that's going to get you where you want. So we could start with something like, well, what two different pairs of numbers multiply to be the same value? So we could do something like 6 and 2 and 3 and 4. Okay, so now, right now with no negatives, this is not going to work out. But if we were to add like and just put like say a negative right here, now again, we're kind of ignoring the whole greatest part. But if we do this, well, we have the first values here are going to be -24. And then the outside is going to be plus 12i. Inside is going to be plus -12i. And that's where that whole imaginary component goes away. And then we can't forget about this. We plus 6i squared. Okay. So at this point, what's going to happen is that these, I guess we could pick a different color. These are going to become a zero pair. And then we have this right here becomes 6 times -1, so we get plus -6, and this is going to be a value of -30. So that's not great in terms of the greatest possible value, but it begs the question then, well, we can clearly actually have a real number product, but then what do we actually do here? And so you start to think, well, okay, we made 12 here. Are there values that we can make that are bigger than that? Maybe 24, maybe 36. And thinking about, well, which ones actually are possible? It's important to realize that we have integers -9 to 9. So if we were just using 1 to 9, then that's problematic. But if we're doing it with integers, we have a lot more options here. So we could think about something like, getting this a little bit cleaned up here. We could think about something like maybe it's 6 times 6. We'll come back to that. You can't do that. And 9 times 4. So we cannot actually have two 6s. So if we make one of them negative, now that doesn't break the rule. The question is this the greatest possible value that we can get? And does it actually eliminate the I terms? So let's try that again. 6 times 4 is 24. Then we have plus -36i. Then 9 times 4, we have plus 36i. And then finally we have 9 times -6 is plus -54i squared. And so again, these terms right here, they cancel out. And so now we have 24 plus, well, I squared is equal to -1. So -54 times -1 gives us 54. And we have 78. Now, I don't know, maybe this is not the greatest possible value that we can make. But this is the kind of idea that if we're just guessing and checking, this is going to take a very long time. But if we're thinking about this conceptually, this is something that we can work through. So I would love to know how you thought about the problem. Can you think of a greatest possible value that is greater than this one? I'd love to know. Let me know in the comments.